Something uninvited has slipped into our celestial backyard. It's neither a planet nor an asteroid. This is 3I Atlas.
3I Atlas has just done the unthinkable. It has grown by 250% in size almost overnight. NASA scientists are struggling to explain how something drifting through space could suddenly expand as if alive. The deeper they look, the stranger it gets. And one chilling question now hangs in the air. What exactly is 3I Atlas becoming? Stay with us to know the chilling details. The visitor that shouldn't exist. Something strange has entered our solar system this year. It is not a planet or an asteroid. It is not even from our solar neighborhood. This mysterious object is called 3I Atlas, the third interstellar visitor ever discovered after Oumuamua in 2017 and Borisov in 2019. But unlike the others that passed by quickly and vanished, Atlas behaves in a way that scientists have never seen before. The object was first spotted on July 1st, 2025, by the Atlas telescope in Chile. At first, it looked like a small point of light moving slowly across the stars. Nothing about it seemed unusual until scientists started to study its motion. That was when everything changed. The object was moving at a speed of around 137,000 miles per hour, which was far too fast to belong to our solar system. It meant that this visitor came from deep space, traveling from the region between the stars. NASA soon confirmed that Atlas was moving on a hyperbolic path. This means it is not bound to the Sun by gravity and will pass through our solar system only once before leaving forever. Its path seemed to come from the direction of the constellation Sagittarius, which is near the center of the Milky Way galaxy. This suggests that Atlas has been traveling for millions, perhaps even billions of years before arriving here. At first, scientists thought it was a comet because it appeared to glow with a faint tail. But something about it was different. Interstellar objects are usually small, faint, and move very fast. Atlas, however, was brighter, slower, and larger than expected. Early estimates suggested that its core could be anywhere between 400 meters and 5 kilometers wide. Its reflected light also looked redder than normal, which could mean its surface is covered with thick dust or metallic grains. As more telescopes focused on it, the mystery deepened. Its brightness changed in unpredictable ways. The light it gave off did not match any known comet behavior. Even its structure seemed to shift slightly, as if it were alive. Every new observation raised more questions than it answered. Was Atlas made of material we have never seen before? Or was it something entirely different from what we thought? Scientists were confused, but fascinated. Then something happened that no one expected. The data coming from observatories around the world began to show strange results. 3I Atlas was not staying the same size. It was expanding at an incredible rate, and no one could explain why. Something in the dark of space had started to grow, and it was growing fast. The impossible growth. The data showed that 3I Atlas was getting bigger. Scientists thought maybe it was a technical error or a problem with the telescope's sensors, but when observatories from different parts of the world checked the same thing, the results were identical. The object had suddenly grown by almost 250% in size. Something in deep space had expanded, and no one knew how or why. Normally, when a comet approaches the Sun, it begins to lose material. Heat causes the frozen gases and ice to turn into vapor, and the comet becomes smaller as it sheds dust and gas into space. But 3I Atlas was doing the opposite. It was not shrinking or breaking apart. It was swelling, as if something inside it was pushing outward. Its surface seemed to expand evenly in all directions, not randomly like a normal comet. Scientists began to call this strange process structural inflation. They had no better words for it. The object's light curve, which shows changes in brightness, remained steady, even though its surface area was increasing. This meant that the entire body was growing, not just forming a larger cloud around it. Some experts compared it to a machine quietly unfolding itself in space. The growth was not only visible in one place, it was confirmed by instruments on several continents,
moving along at an unusual trajectory,
and through different wavelengths of light. Every new measurement supported the same conclusion. 3I Atlas was physically expanding. This was not a comet releasing gases. this was something far more complex. Some researchers wondered if new material was rising from inside, while others thought that the object might contain unknown reactions under its surface. Theories began to form quickly. Some scientists said the sunlight might be causing a chemical change, creating gases that pushed the outer layer outward. Others argued that maybe the object had a hollow structure, and internal pressure was forcing it to inflate like a balloon. But none of these ideas matched the observations perfectly. Whatever was happening to Atlas did not fit into the rules of physics as we know them. As the days passed, the numbers kept changing. 3I Atlas was no longer behaving like a comet or an asteroid. It was behaving like something that had been designed to react in a specific way. The data was so consistent that it seemed planned rather than accidental. And then came an even bigger mystery. When astronomers compared its mass with known comets, they realized it was far heavier than anything expected. A weight the solar system can't carry. When scientists calculated the estimated weight of 3I Atlas, what they found was beyond imagination. It was not just heavier than any known comet, it was heavier by a scale that did not make sense. Some calculations showed that Atlas could be thousands of times heavier than Borisov, the interstellar comet discovered in 2019.
Discovered the first interstellar comet zipping through our solar system, 2I Borisov.
The estimated mass reached tens of billions of tons, enough material to form a small asteroid. This raised serious questions. How could such a massive object travel through space for so long without being broken apart by collisions or pulled off course by gravity? Interstellar objects are usually small fragments of rock or ice that are thrown out from their home systems during planetary formation. But Atlas seemed whole and complete, as if it had been protected or shaped by something far stronger than nature's random forces. If the calculations were correct, it would mean one of two things. Either our understanding of interstellar debris was wrong, or something unusual was launching large objects into space. Scientists were stunned. According to all known data, the galaxy should not be filled with heavy, perfectly shaped interstellar bodies. The chances of one entering our solar system every few years should be close to zero. Yet here it was, 3I Atlas, calmly moving through the solar system as if it belonged here. As the research deepened, scientists noticed something else. The object was not showing any signs of stress. Despite crossing gravity wells and radiation zones, it remained stable and unchanged. A comet this large should have cracked, shed layers, or reacted to solar pressure, but Atlas seemed to glide effortlessly. Some astronomers began to whisper that its strength did not match any known material made by nature. It was almost as if it had been built, not formed. Of course, no one wanted to say that out loud. The scientific community prefers natural explanations, but in private discussions, many experts admitted that the numbers did not fit. The density, the weight, the stability, nothing followed normal comet behavior. Atlas did not appear to be a random piece of rock thrown from another system. It looked precise, controlled, and complete. And as scientists started mapping its orbit, the mystery only deepened. Because the path it followed through our solar system was not chaotic or tilted like most interstellar visitors, it was smooth, organized, and perfectly aligned with the same plane on which our planets travel. That discovery changed everything. Atlas was not just a heavy object from another star system, it was moving on a route that seemed too perfect to be a coincidence. The perfect trajectory. The deeper scientists studied 3I Atlas, the more unnatural its journey appeared. Most interstellar visitors enter the solar system at random angles, cutting through the planet's orbits like skipping stones across water. But Atlas was different.
3I Atlas is streaking through our solar system right now.
Its path aligned almost perfectly with the ecliptic plane, the flat imaginary line where all the planets, including Earth, circle the Sun. The chances of that happening by accident were almost impossible. When astronomers first noticed this, they checked the data again and again, using multiple observatories and software models, but every result confirmed the same thing. Atlas was moving in harmony with the planets, not cutting across them. It followed the same invisible track as if it had been carefully placed there. Usually, interstellar objects approach from strange directions because they come from other star systems. There is no reason for them to match our solar geometry. The odds of one entering at the same angle as our planets were estimated to be 1 in 500. Yet Atlas was doing exactly that. Some researchers suggested that maybe the object had been pulled into this alignment by gravity from other planets or the Sun itself. But when they ran the simulations, the math did not support that idea. The path was too precise and too steady to be shaped by random forces. Others thought maybe it was just a coincidence, but the probability was so low that it left even the calmest scientists unsettled. This perfect trajectory gave everyone a clear view. Telescopes on Earth could track it continuously as it traveled. Space observatories had no trouble capturing its movement. It was almost as if Atlas wanted to be seen, as if it was moving in the most convenient way for humans to study it. The more data that came in, the stranger things got. Unlike most comets that spin or wobble slightly, Atlas moved smoothly and with balance. It did not tumble or drift off course. Its motion was quiet and deliberate, almost peaceful, but too precise to ignore. For some astronomers, it was the most cooperative trajectory they had ever seen. For others, it was a warning sign. Natural objects rarely behave this perfectly. If Atlas was following such an exact path, something about it might be controlling that motion, something we do not yet understand. And just when everyone thought they had seen enough surprises, a new observation came in. Atlas had started to vent gas and dust, just like a normal comet, but even this simple act broke every rule of physics. The coma that doesn't push. By early October, astronomers began to notice that 3I Atlas was becoming more active. Its surface started to release jets of gas and dust, forming a faint glowing tail. This behavior made scientists think of comets, which usually heat up when they move closer to the Sun. But something about Atlas's activity was completely wrong. Normally, when a comet releases gas, the escaping material acts like tiny rocket thrusters. Each burst of vapor gives the object a small push in the opposite direction, changing its orbit ever so slightly. It might drift a little off course or start spinning differently. This is called a non-gravitational motion, and it happens to almost every active comet. But with 3I Atlas, that change never came. Its orbit stayed exactly the same, no matter how much gas it vented. Its rotation period, about 16 hours, remained constant. There was no wobble, no acceleration, and no shift in its path. The comet looked alive with activity, but it moved as if nothing was happening. The models predicted that it should have changed position slightly, yet the data stayed flat. Scientists thought maybe the gas jets were perfectly balanced, pushing in opposite directions so that the forces cancelled each other out. Others argued that Atlas might be unusually dense, so heavy that the gas jets could not move it, but the more they studied it, the less sense those explanations made. The tail was bright and active, which meant the outgassing was strong. Even a small imbalance should have caused some movement. The stability of 3I Atlas became one of its greatest mysteries. It behaved as if something inside it was absorbing every impulse, preventing even the slightest disturbance. It was as if the entire structure was being held steady by an unseen mechanism. Scientists had never seen anything like it before. The images taken by telescopes showed an object full of motion, but untouched by chaos. Gas was flowing, light was scattering, and dust was expanding into a halo around it. Yet beneath all that movement, Atlas remained silent and firm, like a massive anchor in space. Some experts began to wonder if there was more to this object than ice and rock. Its perfect balance hinted at an internal design or a structure far stronger than anything nature usually builds. But no one dared to say it out loud. Then something even more disturbing appeared in the data. When geometry breaks. For centuries, astronomers have relied on one unbreakable rule of comet science. A comet's tail always points away from the Sun. This happens because sunlight and the solar wind push dust and gas outward, forming the long glowing tail we see from Earth. It is one of the most predictable patterns in astronomy. But when scientists studied 3I Atlas closely, they discovered something that made them question everything they knew. The data from 3 observatories showed that Atlas's tail was slightly tilted toward the Sun, not away from it. It was only a few degrees off, but that small difference survived every test and correction. At first, researchers thought it must be an error in calibration or atmospheric distortion, But as more measurements came in, the strange result kept appearing. The direction of the tail was real, and it was wrong. This finding caused quiet shock in the scientific community. In physics, geometry is not supposed to fail. It is the foundation of how we understand space. If radiation pressure pushes dust in one direction, it cannot suddenly push it the other way. Yet, 3I Atlas seemed to be doing exactly that. Its dust and gases were moving as though held in tension by an unseen force.
These dust particles that redden it would also be pushed by solar radiation pressure behind the object. We don't see that, so...
The more accurate the readings became, the more deliberate the alignment appeared. The particles seemed heavier than ordinary dust, but reflected light like something metallic. Whatever was causing this strange geometry was not following known natural laws. It was as if the basic rules of sunlight, radiation, and motion were being rewritten. In official reports, the anomaly was quietly described as a tail vector deviation. But behind that calm language, scientists knew they had witnessed something serious. If this rule could fail once, it might fail again. And if geometry itself could bend, then everything they thought was constant in the universe might no longer be certain. When astronomers traced Atlas's path backward through the galaxy, they found something even more unbelievable. The object's journey did not match the movement of nearby stars. It seemed to have come from a much older region of the Milky Way. The forbidden question. When scientists traced the path of 3I Atlas backward through time, the story that unfolded was astonishing. Its motion through space did not match the flow of nearby stars or the spiral arms of the Milky Way, where our sun was born. Instead, it matched the movement of stars from the thick disk of the galaxy, a region filled with ancient suns that formed long before our solar system existed. This meant something incredible. 3I Atlas could be older than Earth. It might have formed more than 7 billion years ago, during a time when the galaxy was still taking shape and heavy elements like iron and carbon were scarce. If this is true, then Atlas is not just a visitor. It is a fossil from the early days of the Milky Way, a frozen memory of a time long before humans or even our planet existed. The James Webb Space Telescope and other observatories began studying its chemical makeup. What they found only deepened the mystery. The comet released enormous amounts of carbon dioxide compared to water vapor, which is the opposite of what scientists usually see in solar system comets. Its surface also showed traces of materials exposed to radiation for billions of years, suggesting it had been drifting through interstellar space for ages. But even these findings did not explain everything.
In these 100 hours of astronomy, we are going to observe different kinds of objects. We are observing
the object's mass, perfect stability, balanced jets, and strange geometry were too precise to dismiss as coincidence. In private discussions, a few scientists began to ask the question no one dared to ask in public. What if 3I Atlas was not entirely natural? The idea sounded impossible, but the data seemed to whisper it. Its perfectly aligned orbit, its structural balance, and its refusal to behave like a normal comet raised doubts that would not go away. A small group of researchers ran computer models using artificial materials such as hollow alloys or dense cores to test whether these could reproduce Atlas's movement. To their surprise, the results worked. The simulations matched the observations more accurately than natural models ever had. No one wanted to use the word artificial. Instead, they called it structured material or non-gravitational origin. The scientific world prefers cautious language, but the meaning behind those words was clear. If Atlas was truly ancient and possibly designed, then it might not be just a piece of cosmic debris. It could be a relic, something created in another time by something we do not understand. If 3I Atlas is not just a comet, then who or what set it on a path that led it straight to us? What do you think about it? Share your thoughts in the comments.